I'm very, very happy to have with us Peter Fath, who has to share a lot of experience on designing factories. And yeah, Peter, the floor is yours.
Thanks a lot, Michael, for your kind introduction. And I'm very happy to give a speech out of the Western world, how we can move forward manufacturing. So now let me try to operate the slides. I hope you can see my slides now. Good. So the speech is about building new capacities in cell and module at competitive cost. Of course, at the current price level, that's a big challenge. But let us see how far we can go. So quickly, RCT Solutions. We are a German, India, Turkey, China-based engineering company who is setting up gigawatt factories for a number of clients. And we have also RCT Power, a sister company, who is a battery and inverter producer. And we just started RCT Hydrogen to do the same, what we are doing for solar manufacturing for hydrogen as well. Good. Currently, we are covering, and we have been covered about 62 factory projects globally, all over the world, in 21 countries, with a total capacity of 72 gigawatts. Those projects are at different stages. Some are sales stage, feasibility, pre-feasibility, conceptual engineering, basic engineering, or in execution. You see strong position in India and Europe. Then Africa is coming, and MENA region is coming. And also, of course, Canada and USA is also catching up to set up manufacturing capacities. Good. Now I will talk about why it's important to talk about integration, why cell and module integration or even further would be required. And then what is required to set up such capacities, because those countries, most of those countries don't have a gigascale manufacturing, what type of subsidy schemes are available. And then, of course, I will touch base with the cost, because that is one of the key, how we can reach competitive cost outside China and Southeast Asia. And then I will give some examples, so we are not only in PowerPoint. Good. Now the value chain looks like this. So when we are setting up cell and module production, then it's not only needed to look at to prepare the factory and to get the machines and to ramp up the factory and to get the people on board and train the people. Also, we have to look at the supply chain. So it's all about getting access to silver, to paste, to screens, to chemicals, to gases in those countries, which sometimes is a challenge because we cannot find huge gigawatts required amounts in locally. So we have to look at where to import those products to run the factories. And in module, it's of course the same. There, the key issue is glass, how we can get sufficient glass, because if you have to ship glass over long distances, that adds on to cost. So, and we have a lot of regulations for glass imports, especially in Europe. Then we have to look at the encapsulation material, because we have to use advanced encapsulation material, because we have to a certain long lifetime of modules. Then, of course, aluminum frames, that's less critical. And then junction box and ribbons. And of course, the cells, which are coming from us. And for the cell factory, of course, the wafer has to be found. Good. So it's not all about the factories. It's challenging enough. It's again setting up a whole ecosystem for cell and module production in those countries. Why it's good to look at the whole ecosystem, not only at one part like module, because they have a lot of added values when you have an integrated approach. If you have a cell and module integrated factory, you can have a better, you can save packaging and shipping costs. You can easily process optimization, because as you know, there's a lot of impact on the cell design and cell details, on the module performance and module power. And of course, you can optimize your OpEx when you have a cell access to cell and module. I don't say you have to necessarily make cell and module at the same stage, at the same capacity. You can partner with cell makers and make a module factory, or you can set up an integrated factory, or you say, I just want to be the leading cell provider in my country, and I will serve 4 or 5 modules, players around it. But at least you have to ascertain that this ecosystem and this integrated approach is available. So you are not shortage of cells, or you're not shortage of wafers or of material. Good, then especially when we talk about Western countries, it's not all about having a cheap product. It's also looking at environmental, social, and legal and legislation aspects, regulations. So especially European countries are looking now at the CO2 carbon footprint for such products that is required. And that is something which you have to consider at the first day of your factory. So you should be well aware of the local regulations. For example, in USA, you have customs which are applied. You have to show supply chain traceability. So please make sure when you set up your factory in your country that you can satisfy the local regulations in ESG, especially. That has to be considered for Western factories. Now, looking at the support structures, you have seen a big number of projects in India, which we are covering. So India gives a very strong support scheme. It's called productive linked incentives. So when you produce a product, you get a product watt peak related incentive, which helps, of course, so the capex and opex, so all your costs are somehow leveraged by this government incentive. We have another strong support in USA with the IRA, Inflation Reduction Act, where you get tax credits. We have countries like Turkey, which I will show as an example. There we have different forms of subsidies, tax, energy subsidies, labor subsidies, and also some market protection mechanisms are in place. Europe is warming up. We have mentioned the Net Zero Act before. So I think the Net Zero Act implementation, which will require that about 40% of the 2030 products have to be, solar products have to be made in Europe. That's a regulation, if it's played strong, will help local manufacturing as well. So this I will skip. Now let us look at the giga scale. Here you see what is a benchmark. Of course, a benchmark is always China. We have huge capacities in the 800 gigawatt after 2024. Big players which are running at 50 to 100 gigawatt of capacity. So when you start as a new player in the Western world, then of course that's your benchmark. But the issue is it's no meaningful to set up a 50 gigawatt or 30 gigawatt facility immediately in a given country, even in Europe, because you need a lot of people, you need to ramp up, you need to develop the ecosystems. So we are always saying start step by step. From the commercial aspects, it's not needed to have a 20 gigawatt of production facility to be cost competitive. If depending on module, a highly automated gigascale factory can be sufficient for good cost leveraging. For cell, it should be more than 2 gigawatt to have a good commercial leverage. Now let us look at the execution. This is a 10 gigawatt integrated factory, but I highlighted in red the cell and module part. If you want to know roughly 5 giga or 1 gigawatt scenario, you can just divide it by the related factor and put a little bit mark up, because if it's a smaller scale, then there's a little bit more overhead cost applied. So typically our observation to set up a cell factory in the Western world from the first idea, including feasibility, engineering, permitting, financing, and then preparing the buildings, ramping it up to full capacity, train the people. That takes typically 1.5 to 1.5 to 1.8 years. So it's not like in China, when you have the idea, 3 months later you have the financing, 6 months later the factory is running. We need more time to prepare our factories, especially since our permitting agencies are not very, how shall I say, experienced on such type of gigafactories. The permitting can take 2 to 9 months. That comes extra. But I think after the first phase of implementation of gigafactories is done, the permitting will be much faster to be done. And then, of course, you see the manpower requirement. So we are always short in manpower in the Western world, typically. So that means we only can accept factories in the Western world with a very high degree of automation, because we are lacking normally of people. Of course, in India, you have more people. Perhaps you can compromise on the level of automation, but in the European cases, in the North American cases, you need the highest degree of automation for such type of factories. From the investment numbers, that of course is strongly varying, because some countries prefer local equipment vendors to be used. Then we have certification standards, UL certificate for the machines or CE certificates for the machines. So that can vary, then can change the capex. Even you make an apple-to-apple comparison between Western and perhaps Asian equipment, that can vary between 10 to 30% the capex. Then if you increase the automation, degree of automation, then you add another 10 to 15% on the capex. But of course, you save on the manpower. So that's module factory in the Western world. I would say typically from the first idea to get the factory full running, we are talking about 1.2 years, 1.5 years. Always keep in mind, if the building is available, the permits are done, then we can supply and get it in six months and ramping up in 2 months. But the permitting takes time, and the financing in this very harsh competitive environment, that takes time. Good, now coming to the one key findings. So we have made a calculation on the component-wise cost of ownership, assuming a 10 gigawatt factory breakdown, using 4 different cell technologies as a basis. And not all the value chain is not based on a non-profit assumption. So if we compare here, we have, of course, the benchmark is always China. Let us look at TOPCon. So according to our assessment, if you include non-subsidized costs, 0 subsidies are included in this model, then we might be between 15 to 16 euro cent per watt peak. The next country, if you look at North Africa, the MENA region, we have a very good cost location in Algeria. We have cheap electricity, reasonable low labor cost, and that of course helps to reduce the cost. And we have local glass production, which can also be done cheap because of the natural gas available in Algeria. So that means we can make it about 2 cents, 2.5 cents, a little bit higher than to China. Then India comes at the same level, 19 cents per watt peak, fully integrated module cost using TOPCon. And then we are moving to Western countries like Germany, Norway, USA. There, of course, we have the increased labor cost, because typically Asian factories are running at 3 shifts. Western factories have to run at 5 shifts. And that, of course, apart from having higher labor costs, that adds on the more shifts you require, you need more labor cost, and that adds quite substantially on the cost. Electricity in the Western countries is getting cheap now, because we're using more wind and solar in different countries. So electricity is not a headache anymore, but labor cost, that's still something which has to be further reduced by having a high degree of automation. So that means if you compare China on the TOPCon case with USA, we are talking about a 10 cent per watt peak count difference. All is unsubsidized. 0 subsidies are applied, and pure costs are calculated. If you compare now the different technology like heterojunction, you see there's a small premium to be paid to heterojunction. We can assume about a 2 cent extra is coming as compared to TOPCon. And if you have a back contact, depending which type of back contact cell you make, you can come at a similar cost. Of course, the price breaker is always still PERC. So PERC is in China, in India, in the Western world, the price breaker. There we can make the lowest cost modules if we use PERC. Good, so that means now coming to some examples. So running factories we have in the world. We have one factory which we have been involved as RCT in Turkey, Kalyon PV. That's a 2.1 gigawatt module, 1 gigawatt cell, and nearly 750 megawatt ingot and wafer, located in Ankara, running on mono PERC. You see the building. It includes ingot, wafer, cell, and module, and the related utilities you can see. And there is a connected 1.3 gigawatt power plant in Karapınar in Turkey, which is only using that Turkish-made modules, glass module, mono PERC with a single axis tracker. That factory is, that power plant is accomplished already. Then another project is Adani, that's a big player in India, who is also looking at the full supply chain to be developed in India, from polysilicon, ingot, wafer, cell, module. All this one will come in 2 phases. Then, of course, Tata, that's a cell and module integrated factory project, 4 gigawatt each. It's already in the commissioning stage, so and the module factory is already running. Then we have a project in Canada, which is another fully integrated factory project, starting from a big quartz deposit in Canada, Manitoba, and that also will include all stages of the value chain, but as well cell and module, of course, glass, silicon, and ingot and wafer. Then we are coming to Europe. That's Carbon project. That's a 5 gigawatt project. Permitting is on the way. Site location selected in Fos-sur-Mer, in south of France, close to Marseille. Integrated factory, ingot, wafer, cell, module, TOPCon, and back contact cell technology will be used. And then another project, this is first a module factory, later on integration will come. That's Nordscell in Sweden, North Sweden, with a fully integrated, fully automized 1 gigawatt module factory, later to be further integrated. Sweden is a very good location because you can have very cheap CO2 neutral hydropower in Sweden. So that's another good and beautiful factory. So my conclusion, local manufacturing can be done. We have to take precautions. It's not like copying the Asian experience and put it into Western countries. You have to look at local regulations. There's a big demand for locally made product. You have to work at the full supply chain, not hammering a factory into a ground and look where the glass and all the components are coming from. Capacity should be in the giga scale, 1 to 2 gigawatt minimum. If you're integrated, perhaps 2 to 5 gigawatt. If you look at true cost, you see there's a cost difference between those countries. But if it's all unsubsidized, there are other good cost locations available, like in MENA region in India, which can be at a similar cost level as China. And please take into account environmental aspects when you prepare your factory, because that is required in the Western world. Thank you so much.
Thanks, Peter. Very interesting. I think we have you later on the panel, but maybe one question, because we still have a bit of time. So when you look at today's situation, so now we have all this overcapacity, there's all these cost pressure, prices are low. Even this year, prices continue to decrease a bit all along the value chain, from silicon even to modules. They also got still a little bit down. Of course, it has flattened over the last few weeks. But how is the interest now from new players? So we've been seeing, of course, that the big ones have mostly delayed, but you showed also in your slides actually that they still have big plans. If you look at the recent Q1 numbers from Longi, from Jinko, they still have higher targets for end of this year. It's a lot about also market shares, I believe. But how do you see that if you, I don't know, look a year back when sort of everyone wanted to go into manufacturing still, and still kind of being very upbeat after the pandemic, the supply chain crisis. So and today's situation. So how has it changed from your point of view? Because a lot of people are coming to you to ask you.
Yes, I mean, generally, of course, if you look from the PERC perspective, with that price levels, and you saw the manufacturing cost, and you saw the difference in prices. So the manufacturing cost and prices are currently not fully matching. So but still, I observe an increasing demand coming to RCT Solutions. There's an increasing number of projects coming to us. And that gives me a certainty, Michael, that, I mean, we have seen these cycles. Prices are crashing down, prices are recovering, prices are coming up. That will come. And if you want to be in, you should prepare your factory now in a little bit, so let us say a little bit downturn. So that's one. So it's the right moment to look at in a solar factory investment. Second, it's a per se fact that this resilience, having and supply locally, that is something that's a fact. And that's not all driven. Of course, you cannot make a solar factory which is a triple cost as compared to Asian suppliers. So you have to be in a certain cost corridor, that's sure. But with a high degree of automation, which then reduce the impact of labor cost further, and the cheap electricity from renewable, which is available also in the Western world, I think this cost difference, if you talk about unsubsidized cost, the level playing field is shrinking. And then this argument of we won't have local products, we won't have a traceable supply chain, starts to play stronger and stronger and stronger. And that is why we see, and really, I cannot say others, that we are seeing now an increasing demand of customers coming to us saying, I want to have my factory in 1 to 2 years. Interesting.
Good. I think that's nice. So we follow up later on the panel. We have many more questions. Thanks, Peter. Then we could